If you're struggling with anything from section 9.4, that was all about solving quadratics by taking square roots. So we used our knowledge from section 9.3 to help us be successful at this. In problem number 11, we want to get m completely by itself. That's always the goal when we're solving. So the first thing I'm going to do is I'm going to add 3 to both sides. So I'm going to get m squared equals 25. Now, I want to solve for m. So I want to take the square root of both sides. So I get m equals positive and negative 5. Remember that a positive 5 times a positive 5 gets us a 25, but also a negative 5 times a negative 5. So if you don't like writing it like that, you can write it as m equals 5 and m equals negative 5 as well. All right, in problem number 12, again, same idea. We want to get the variable completely by itself. So for that, I'm going to subtract 2 from both sides. So I get n squared equals 11. Now I'm trying to get the variable completely by itself, but I'm squaring it. So in order to undo squaring it, I'm going to take the square root of both sides. So n equals plus or minus just the square root of 11. There's nothing that I can do to simplify the square root of 11. There are no perfect squares in it. The next problem we have is 13. Again, the first thing you want to do is try to get the variable completely by itself. So my first step here is to add 9 to both sides. So I get 3k squared equals negative 31. Now I'm trying to get the variable completely by itself. It's currently being multiplied by 3, so I'm going to divide both sides by 3 and get k squared equals negative 31 over 3. Now again, I'm trying to get the variable completely by itself, so I'm going to take the square root of both sides. The square root and the squared cancel, and I get k equals the square root of negative 31 over 3. Can I take the square root of a negative number? No, we talked about that a ton in section 9.4. A negative times a negative makes a positive, and a positive times a positive makes a positive. There's no way to make a perfect square out of negative. There's no way to get a negative number and inside a perfect square that we know of, at least in this Algebra 1 class. So we are going to say there is no solution to problem number 13. And our final problem from section 9.4, again, we're trying to get the variable completely by itself. So we're going to add 8 to both sides first. So I have 2k squared equals 56. Now, again, trying to get the variable by itself. So I'm going to divide both sides by 2. I get k squared is 20. What would that be? 27? No, 28. Yes, 28. Okay, so we want to get the k completely by itself. We're going to take the square root. Remember, the square root and the squared cancel each other out. So I get that k equals plus or minus the square root of 28. But let's think about 28. Are there any perfect squares inside of 28? I'm thinking 4 times 7. All the 4s in here, those have been all the perfect squares in this practice test. So that means that I can rewrite the square root of 28 as the square root of 4 times the square root of 7. And what is the square root of 4? It's 2. So you can write your answer to problem 14 as this, k equals plus or minus 2 square root of 7. Or you can write it as this, if you want to write it separately, so that way you can more visually see that there are 2 answers to that problem. So that's your review for solving quadratics by taking square root, section 9.4.